So we have 4 speakers who will be presenting in this session. So may I invite the first speaker, Mr. Muhammad Fahry, to come on stage to present his talk with the title Linking Extreme Rainfall Variability to Hydrological Alteration in a Tropical Sub-Watershed. Evidence from the Biyonga Sub-Watershed in Indonesia. Thank you.
Alright, good afternoon everyone. Thank you for this opportunity. It's a pleasure to be here. My name is Fahry Djuraini. Actually, I am a master student from the Faculty of Geography, Universitas Gadjah, Mada, Indonesia. Today, I will share to you all our research with the title Linking Extreme Rainfall Variability to Hydrological Alterations Evidence from Biyonga Sub-Watersheds, Indonesia. So first of all, for the introductions, we all agree about the climate change. It may affect all aspects of our life. So the global shift in atmospheric circulations may change in the intensity and also frequency of the extreme rainfall behavior. And at the end, it alters the regimes, rainfall regimes, and also extreme behavior of our response of our catchment area. So based on the IPCC report in 2023 about heavy precipitations over lands, you can see at this infographic specifically about the 10 years event return periods they projected in the future. With the optimistic and worst case scenario, it's increasing 6 until 30% wetter for the intensity and also 1.3 times until 2 times for the frequency of the 10-year return period events. And unfortunately, specifically for our location study, our scope of Sulawesi Islands, the rainfall intensity research focusing on the magnitudes of the extreme rain events, it's well documented, and for the rainfall frequency, it's often overlooked. So we have one simple question: which aspect of the rainfall extreme variability actually controls the hydrology in Biyonga Sub-Watersheds as our location study? So we have 4 objectives. For the first, we try to identify rainfall extreme variability using the principal component analysis. And next, we try to detect when the hydrological regime shift and when the change points years in the past. And after that, we try to assess the degree of hydrological alterations using the indicator of hydrological alterations framework. And finally, we try to analyze and understanding how the correlations or relationship between the rainfall component and also the streamfall index from the indicator of hydrology alterations. So this is the research locations. This research conducted in Biyonga Sub-Watersheds. It's relatively small, only 72 square kilometer. Actually, it's a part of the main river basin in Limboto watersheds in northern Sulawesi Islands in Indonesia. You can see this is the index map. This is the part of the Limboto watershed and the northern of Sulawesi Island. So this is the data and methods we use in our study. Actually, we use the continuous daily records from 18 years. It's covered from 2007 and 2024. And we have 2 main data analyzed in our study. For the first is rainfall data. It's come from the 5 stations around the catchment area. And the other hand, we use the discharge data. It's come from 1 stations in the outlet of our catchment area. So for the rainfall data, we start analyzing using the climate index, specifically for the extreme rainfall index. Recommended by the ETCCDI, we have 14 parameters of extreme rainfall index we analyze. After that, we use the principal component analysis to reduce the redundancy and multicollinearity of this data and to extract which component is specifically for our catchment area. And the other way, the discharge data we start analyzing using the man-candle trend test and petit test to find when the change points or the regime shift in the past. After we found, we separate into 2 periods, before the change point and after the change points, and we analyze the degree of alterations using the 333 indicator of hydrological alterations. After that, we try to find which indicator is significantly changed before the change point and after change points using the man-Whitney U test. And then, but of this result from the principal component analysis and the indicator of hydrological alterations, we link using the correlations Spearman to understanding how the relationship between each other. So first, this is the first result about the rainfall extreme. You can see this is the figure 2. It represents about the eigenvalue distributions and cumulative explained variance from the PCA from the 14 parameters of extreme rainfall in our catchment area. Actually, we found only 2 components. It have a greater one eigenvalue and also have the cumulative variance contributions up to 87%. It means we can use only these 2 components to understand all of these 14 parameters of extreme rainfall in our catchment area. So the results we called for the first component, it represents about the rainfall intensity or PC1. It's included with the dominant parameter. You can see at the table 3, the dominant parameter of the PC1, it's simple daily intensity index, extreme wet days, and also RX1 day and something like that. And for the second component, it's represent about the frequency and persistency of the rainfall extreme. It's represented by the dominant parameters such as consecutive dry days, heavy precipitation days, and other. And move to the hydrological regime shift. We have 2 panels in here. Panel A, this represent about the monthly discharge time series, and the panel B is represent about the main canal and petty test statistic. And we found the change point is significant in August 2013. So we separate the temporal time series into the 2 periods. Before the change point, it's called pre-change, covered from 2007 until 2013. And after the change points, it's called the post-change, covered from 2014 until 2024. And actually, you can see the behavior of the monthly discharge time series is very different before the change points and after the change points. Before the change points, it's very fluctuative. So after that, we try to analyze the degree of alterations, hydrological alterations, and we found overall alterations almost 40%. So it's classified as moderate alterations. And we found the 10 of the 33 indicator of hydrology alterations have changed significantly. So it represents 30% of the total variables in this study. And this is the final result for the linking the extreme rainfall to the hydrology alterations. We tried to analyze using the correlation metrics, and we found the second component, it represents about the frequency and persistency of the extreme rainfall, have a significant driver for the alterations in our catchment area. For example, the second component, it represents about frequency, it have a moderate significant correlations with the date of minimum annual flow, which means if in the future the frequency of the extreme rainfall increase, so it will change the date of minimum of water year, something like that. And also another significant correlations, the second component with the indicator of reversal of discharge data, but they have a negative moderate significant correlation. So when the frequency of the rainfall extreme increase in the future, so it may decrease the reversal of our catchment area, reversal of the discharge data of our catchment area. And for the first component, represent about intensity, have no significant driving relationship to the alterations of hydrological regime in our catchment area. And this is the evidence. So the frequency is controlled the hydrology, the temporal spacing of the rainfall events dictates soil moisture, base flow, and eventual rainfall response more than shear volume. And for the intensity is a secondary for our catchment area. It's very important, also very important for the fast food, but the single day of extreme intensity does not solely drive the long-term hydrological regime shift in our catchment area. And this is very important for the water resources management, must be for the analyzing spell durations, such as consecutive dry days, consecutive wet days, for the future planning. And this is the future research. Actually, we still working about that, but this is the short result I can share to you all. We try to projected the future intensity and frequency of the using the regional climate model based on the CMIP6. This is our research, and we try to create the hydrological model to assess the future peak flow, future flood and inundations, and the future water balance and water scarcity. And for conclusions, so we find the significant regime shift in 2050, and it's occurred the moderate hydrological alterations and altering effect of flow magnitude, timing, and dynamics. For the main insights, the rainfall variability in our catchment area, it's about the intensity and frequency, but the hydrology is strongly linked to the frequency and persistency of the rainfall extreme, and we have no significant link with the intensity of the rainfall extreme. And this is for the implication is very relevant for the climate adaptation and watershed management. And for acknowledgement, I want to thanks for the Indonesian Endowment Fund for Education for the financial support which made this research and publication. possible. Thank you very much for your attention. Thank you.
Thank you, Mr. Fahry, for your presentation. So now I'd like to open the floor to the Q&A sessions. Do you have any questions from the audience? Please, Professor.
Thank you for a very interesting presentation, and it's more interesting to see that there is a big shift in 2014 period, right? Okay, so any reason, have you identified the actual reason for this shift? Is it to do with the greater climate, or is it due to human activities and pathological changes, anthropogenic changes, or what? Have you went into the details of why is there a shift?
Alright, actually our research focused on the impact of the climate change, impact of the rainfall. We don't include the effect from the anthropogenic activity. So maybe in the future we try to improve our methods to calculate which aspect impacting for this regime is about the rainfall and anthropogenic. We try to define about it. So we don't include in this our research.
But have you done a very simple study on the catchment itself? Whether is there any change for the past 10 years on the catchment?
On the catchment, actually for our catchment area, it's only for the land use is increasing, but not significantly for the other sub-watershed. So we select this catchment area because the stable of the land use change not increasing significant in the past.
Quite interesting. Yeah. Okay.
Thank you very much, Prof.
All right, thank you, Mr. Muhammad Fahry, for your interesting presentation. So, in the interest of time, we'll need to move on to the next speaker, but feel free to approach Mr. Fahry for your future questions. All right? Thank you. Please return to your seat. Now, ladies and gentlemen, I realize I forgot